So in the second model, we are going to discuss integration of sin power mx into cos power nx dx. So how do we integrate sin power mx into cos power mx? So there are two different cases in this type of integrals. The first case is when m and n are nice positive integers. So m comma n are positive integers. The second case is when m comma n are fractions. So sometimes it will be given in the question where m and n are some fractions. So first, if m and n are positive integers, this is quite easy to solve. And in this case, there are four subcases. It is first, integration of something like sin cube x into cos square x dx, integration of sin square x into cos cube x dx, integration of sin cube x into cos cube x dx, integration of sin square x into cos square x dx. It is, once the power of sin is odd, the power of cos is even. The power of cos is odd, the power of sin is even. Both the powers are odd. Both the powers are even. We follow different process to solve these different questions. So let us call it A, B, C and D. So if you take the first model, that is 1A, integration of sin cube x into cos square x dx. The process is very simple. So we use a substitution, proper substitution. So the substitution has to be decided like this. So if you have the odd power for sin, so what we do is we separate it into corresponding even power and a single sin x. So from the odd power, we separate a single sin x. So an even power of sin will be remaining, cos square x. Now, if I assume cos x is equal to t, sin x dx will go into dt. That is, let cos x is equal to t implies minus sin x dx will be equal to dt. So this will become cos sin square x is 1 minus cos square x, that is 1 minus t square, and cos square x is t square into minus dt. This is very easy to integrate. This can be integrated easily. So you can directly expand this into polynomial and you can integrate it. It is, if the power of sin is odd and the power of cos is even, whatever is the even power, whatever is the trigonometric ratio with even power, that has to be taken as x. So similarly, if you have 1b, so integration of sin square x cos cube x dx. So here we assume sin x as t. So if you assume sin x as t, this becomes t square, and 1 cos x dx becomes dt, and cos square x becomes 1 minus t square. So when one power is odd and the other power is even, so whatever is the trigonometric ratio with even power, that has to be taken as t. So I hope these two are clear. And once you take the trigonometric ratio with even power as t, the integral will become a polynomial integral. You get the answer. Next, if you go for the third one, integration of sin cube x into cos cube x. So in this question, we can take any of these functions, any of these two functions as t. So if you assume sin x is equal to t. So if you assume sin x is equal to t. So what happens is 1 cos x dx goes into dt. 1 cos x dx goes into dt. So this integration becomes integration of sin cube becomes t cube. So if 1 cos goes with dx, the remaining cos square is 1 minus sin square dt. So you get the integration. This has converted into polynomial. If you expand the bracket, it is t cube minus t power 5 dt. It's very easy to integrate. So in the third model, both are odd. You can take any of these ratios as t and go forward, you get the answer. Now you go for 1D, is both the powers are even. So if both the powers are even, substitution doesn't work. Because if you do the substitution, so let us see the difficulty in the substitution. If you put sin x is equal to t, 1 cos x dx goes into dt, and you have t square into cos x is root of 1 minus t square. So you get a root which is very difficult to integrate. So this is not a good process if both the powers are even. So if both the powers are even, the process that we do is we use trigonometric identities to reduce the power. Say sin square x is equal to 1 minus cos 2x by 2. Cos square x is equal to 1 plus cos 2x by 2. So we use these identities and reduce the power successively, and then once every trigonometric ratio goes to power 1, you can integrate it. That is, if you want to integrate sin square x cos square x, what you do is integration of sin square x is 1 minus cos 2x by 2 into 1 plus cos 2x by 2 dx. So this becomes 1 by 4 times integration of 1 minus cos square 2x dx. So sin square x cos square x, the effective power is 4. Now in one step, the effective power has become 2. The effective power has become 2. Now what we do is again cos square 2x. So 1/4 of integration of 1 is x minus integration of cos square 2x is 1 plus cos 4x by 2 dx. 1 plus cos 4x by 2 dx. So now this has become a single degree trigonometric equation. Now you can integrate this. So what you need to do is, if both the powers are even, you successively use these formulas to reduce the power. So at each stage the power will become half. If the initial power is 4, the next stage the power will become 2. Again, if you apply, the power will become 1, and in the final stage you can integrate the integral. So now let's go to the second type, when m and n are fractions. Sometimes you will be given sine power some fraction x, cos power some other fraction into x dx. So in such cases, the integration can be solved if m plus n is a negative even integer. So whenever you get fractions which needs to be integrated, defaultly m plus n will always be a negative integer. Only then can this integrand be integrated. For example, if you want to integrate sine power minus 7 by 5x into cos power minus 3 by 5x. So first what you need to check is you need to add these two numbers. So minus 7 by 5 minus 3 by 5 is nothing but minus 10 by 5, which is equal to minus 2. So as you can see, this is an negative even integer. Yes, right? Now if m plus n is a negative even integer, this can be integrated very easily. So let me show you the process. So what I do is something like this. So we try to convert this sine and cos product in terms of tan. So what you do is sine power minus 7 by 5x. I'll divide this with cos power minus 7 by 5x. So that I get tan power minus 7 by x. So into cos power minus 3 by 5x is already there. I have divided with this, so I need to multiply with cos power minus 7 by 5x dx. So what is the simplification that I get when I do this? So I get integration of, this is tan power minus 7 by 5x times cos power minus 3 by 5 minus 7 by 5, which is cos power minus 2x dx. Cos power minus 2x dx is nothing but 1 by cos square, which is equal to secant square. That is equal to integration of tan power minus 7 by 5x into secant square x dx. And now the differentiation of tan x is beside tan x. So let tan x is equal to t. This implies secant square x dx is equal to dt. Secant square x is equal to dt. So this becomes dt. So integration of t power minus 7 by 5 dt. So this can be very easily integrated. T power minus 7 by 5 plus 1 by minus 7 by 5 plus 1. That is equal to t power minus 2 by 5 by minus 2 by 5 plus 1, where t is equal to tan x. So the answer, the integration of this is tan x power minus 2 by 5 by minus 2 by 5. So I hope you are understanding this process. So if m plus n is equal to a negative even integer, once you do this process, here you will be left with either cos power minus 2x or cos power minus 4x or cos power minus 6x on. That is, you will get either secant square or secant power 4 or secant power 6. So once you get secant power any even integer, for example, in the next time you get secant power 4, 1 secant square dx goes to dt, the other secant square can be written as 1 plus tan square, and this becomes a polynomial. So whenever m plus n is a negative even integer, you can solve integration of sin power mx cos power mx dx.